Hello, everyone. Today's project will be migrating an existing Amazon Bedrock agent to an AgentCore compatible LangGraph agent. In my previous video, I mentioned that Amazon launched a new service, which is currently in preview, called Amazon Bedrock Agent Core. And we reviewed that AgentCore simplifies building, deploying, and managing and securing AI agents at scale. We also discussed the value of AgentCore is it works with any agentic framework and any foundation model, not just Bedrock hosted models. And for those of you that don't know, Amazon Bedrock is a fully managed service from AWS that simplifies accessing foundation models and provides users additional tools to build generative AI applications without having to manage any underlying infrastructure or perform complex model development. Many of my customers have been asking which platform should they use for developing their AI agents. And it's really use case dependent, but at a high level, Bedrock offers serverless deployment of your AI agents, and it removes the need to leverage an agentic framework like LangGraph or Strands, and it handles agent orchestration through LLM-driven decision making, and it's a relatively low-code service for deployment. AgentCore is great when you need more control over your agent's workflow and decision-making process, especially for complex tool orchestration scenarios. It's also great when you're already working with agentic frameworks like a LangChain, LangGraph, or CrewAI and need to deploy them at scale. And additionally, AgentCore provides capabilities to support both long-term and short-term agentic memory for those more sophisticated agent behaviors. Now, here's something really powerful. What if you already built your AI agent using Amazon Bedrock agents and you decide you want to transition this to an AgentCore agent because you want more control over your agent's behavior? AgentCore includes a migration tool that can convert your Bedrock agent to a LangGraph or Strands agent, and you're able to run that on the AgentCore runtime within minutes. So let's walk through a real example. I have an existing Bedrock agent that's a text-to-cipher agent, meaning you provide a natural language query to the agent, and the agent will convert that query to OpenCipher, the query language, to query a graph database, and it will execute that query against my Neptune graph database, and the graph database results will be sent back to the LLM for the LLM to synthesize the data and provide a natural language completion. So let's view a demo of that existing Bedrock agent. Okay, so I'm in my Amazon Cloud Console, and let's go toward the Bedrock service. And on the left menu, let's go to Agents. I'm going to sort by date, and let's click on our agent. So I have an existing agent called Query Manufacturing Data, and let's take a look at a couple of key values, and we'll need these later. So that's agent ID along with agent alias ID. Just wanted to point those out so you know where to find them, and we'll need those values later. But let's run our test query. We're going to say what parts are needed to build the following component. And we'll maximize this shortly as soon as the query is finished. Okay, so let's maximize this, and we have our completion. So now if we want more details regarding the underpinnings of this agent, like the prompt and what action group or tool it executed, you can see the complete execution flow in the trace logs. So let's go to that and let's view trace step 1 in the orchestration and knowledge base trace logs. And let's scroll up here now. So now you see the LLM info and the inference parameters. You also see the system prompt. And you can observe after the system prompt the chain of thought reasoning that's occurring. And it lets you know what action group that it needs to execute. And action group essentially refers to tools, but it maps to a AWS Lambda function. So it's going to show you the action group that needs to execute to generate the completion. And finally, it will give you the completion. Okay, and there you have it. So now we'd like to transition this Bedrock agent to run on AgentCore. Thus, we need to export its code and convert it to a suitable open source framework like LangGraph or Strands Agent. So let's jump to our IDE to review the next phase of this. All right, I'm in my integrated development environment, and this demo assumes you have the necessary AgentCore Python packages installed. If you need guidance on the packages, please view my previous AgentCore video where I discuss the necessary packages in more detail. Now, let's see how easily we can migrate our existing Bedrock agent to LangGraph. Let's go ahead and run this migration script. And let's maximize the screen, and we'll walk through the details a bit. So you'll be asked a couple of questions during the migration, and we'll say yes, that we want the verbose output, and we'll say no to deploy the agent to the AgentCore runtime. I just want to run it locally. My previous video shows you the process to deploy it to the AgentCore runtime environment, which is not difficult at all. And we want to install all the dependencies and run locally. That's what's selected here. And I'm going to hit enter to that. Now, while this is churning away, let's walk through our script a bit. So you can essentially see that we're launching the AgentCore CLI command and followed by the import agent. And there are a couple of attributes that you need to specify. And it's agent ID and agent alias ID of your existing Bedrock agent. I showed you where to find those values. And for the target platform, I can select either LangChain or Strands. I selected LangChain so it can produce an actual LangGraph graph that we'll walk through. And this will be the respective framework for the Bedrock agent that it will be transitioned to. I also specify the region of my existing agent and the output directory where I want to store the migrated agent. So we still see that this is going, and it's complete already. So now we can ask it our questions. So I'll just cut and paste from the sample queries, and I'm literally asking it the same question that I asked previously on what parts are needed to build the following component. And let's maximize it. And you see the same chain of thought reasoning, and you see the response that it generated. Now, the nice part is that all existing functionality and permissions were preserved. So your Lambda function and infrastructure remain untouched. The only thing that was migrated was that Bedrock agent to an actual LangGraph graph now. And it's essentially still calling that same AWS Lambda function. So nothing breaks in the background. So let's walk through the migrated code. If you see in my agent migration script, I specified migrate underscore agent as the output directory. Thus, we have the migrated agent output directory. And if I go to the files that's generated there, which in this case, it's LangChain agent. And let's go ahead and view this. And so you see all the imports. This is auto-generated. All the imports are there. You see that it's using the chat Bedrock class of LangChain to call our actual LLM. It's bringing those same variables over the inference parameter variables that we saw previously from our agent. You're seeing the actual system prompt, which is the orchestration template, and all the details of that is transitioned over. We actually have a Pydantic schema defined that was auto-defined to store the query in that we send to the agent, and that's passed to our tool decorator, which is also a LangChain LangGraph defined class. And you see the manufacturing queries function. And what this is essentially doing is using Boto3 to call that same Lambda function. So we see all the payload information, and then it's invoking that same Lambda function. And we add that Lambda function as a tool, and we essentially create a graph. So the create React agent is an actual function from an actual LangGraph class that allows us to take in our LLM, our prompt, our tools, our check pointer, which is essentially the memory, and create that graph. And then we just have our actual app entry point on how to invoke that agent. So let's quit this and let's see a more visual view. Now that it's actually a LangGraph agent, we can actually view the agent using LangChain Studio. And so we go in here, and now we see a visual representation of what's happening is we start by invoking the agent, and the agent passes the necessary query to our Lambda function, which is the tool. The tool responds with the actual results from our graph database, sends those results in that feedback loop back to the agent for it to synthesize. Then the agent generates the completion and ends it. So let's go ahead and test a query here. So we're just using that same query. What parts are needed to build the following component? And you see, anytime you see this table within LangGraph Studio, it's executing a tool. And you see that it's saying the tool it's executing is query manufacturing data, which is our Lambda function. That was the action group that existed for our Bedrock agent. And you see that the completion is generated. So that essentially concludes the migration steps. So you saw in a few short minutes, I was able to migrate our existing Bedrock agent to an AgentCore agent, and now I can really literally just do an AgentCore launch or deploy and deploy this agent from local to the AgentCore runtime, and now I can interact with it online. So, and you can also further customize your agent if you want to add additional nodes or edges or API integrations as well. You're not limited to just a Lambda function. That's the beauty of AgentCore. There's more flexibility there. So this concludes our demo. I hope you enjoyed and happy building. Take care.